This is a topical practice, and I put in paper 1, non-calculator paper. But having said that, right, your normally permutation combination should be a paper 2 question because the numbers are quite big. Usually, we need to use a calculator. The NCR, NPR, we have to use calculator. So I tweaked the question in this paper such that all of this can be calculated by using brain without calculator. So I want you guys to not use calculator if possible. Okay, let's begin. Question number 1. Right, Sam has 3 red marks, 2 blue marks. He wants to arrange these 5 different marks in a row. How many ways can he arrange them if there's no restriction? So when there's no restriction, 5 marks in a row, very easy, guys. How many ways to arrange 5 items in a row? Answer, 5 factorial. So 5 factorial, right? If you really cannot count you don't remember, right? Hey, guys, no calculator. If you don't remember, you just use this. Use a simple mental arithmetic. 5 times 2 is what? What is 5 times 2? 10, right? 10 times 12. This is 12, right? What is 10 times 12? 120. So do you really need to use a calculator? 5 factorial you can count mentally. Right? Yeah, even up to 6 factorial you can count mentally. Just times 1 by 1. 5p5 is okay, but the problem with 5p5, right, guys? You need to know the 5p5 formula. 5p NPR is given by n factorial n minus r factorial. So if you want to use 5p5, it's 5 factorial, 5 minus 5 factorial, which is what? What is this? 0 factorial. And what's 0 factorial? 0 factorial is 1. So you end up getting 5 factorial, right? And 5 factorial is basically 5 times 4 times 3 times 2 times 1. So all these, like I say, you can count mentally. Yeah, it's not, I'm not doing like 20 factorial or 10 factorial, right? Just 5 factorial only. Okay, second part. A blue mark is placed in the middle, red mark is placed at each end. So you got 3 red marks, and we'll do 1, 2, 3, 4, 5. I need to put a blue here. Blue, I got 2. I need to choose 1. So I put 1. Red, I have 3. I need to arrange 2. So this is 3 and 2. Sorry, I wrote this wrongly. This is supposed to be 2. We're talking about number of options. This is 2. Sorry, 2. 2 ways. How about the remaining? So the rest, I can put red again, I can put blue again, doesn't matter. Remaining will be 2 and 1, right? So for me, since it's non-calculator, we can just count like this. 3 times 2 times 2 times 1 times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. Isn't it? Can we count using brain without using calculator? Of course. Okay. So I wouldn't use NPR. Now, I know some people say, can I use the red? I got 3, I arranged 2. Then the blue, I got 2, I arranged 1. The remaining, I do 2 factorial. Yeah, this one you need to use a calculator. Or if not, you get, what is 3b2 again? Guys, 3b2 is 3 factorial, 3 minus 2 factorial, which is 3 factorial, right? So it's the same, so I don't do that. I don't do that because 3 factorial divide 1 factorial is still 3 factorial. So I'll rather count 1 by 1 like this, okay, since it's non-calculator. Okay, let's move on to part B. So part A is permutation, part B is combination. So Corinne has 6 different pairs of shoes. In how many ways can she choose at least 1 pair of shoes? Okay, so we can do this, guys. 6 shoes, at least 1. At least 1 is what? 1, 2, 3, 4, 5, 6. Are you going to do 1 by 1? Do you know about this, guys? Do you know that this is like a formula, if you like, NC0 plus NC1, NC2, all the way until NCN is the same as 2 power n. Do you know about this? Okay, let me demo for you. Do you know, for example, Pascal triangle, right? This is 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Okay, do you know that this is 0C0? This is 1C0, 1C1. 0C0 is actually 2 power 0. This one you plus together is 2 power 1. This is 2C0, 2C1, 2C2. You plus together is 4, right? 4 is 2 power 4. This is 3C0, 3C1, 3C2, 3C3, which is 8, right? Sorry, I wrote wrongly. This is 2 power 2, which is 4, 2 power 2. This one is 2 power 3, which is 8. Then this is 4C0, 4C1, 4C2, 4C3, 4C4, which is 2 power 4, 16. So this is something we can use. Okay, now some people still say, Terry, I don't get this. Is there another way to prove it? Yes. remember binomial expansion 1 plus x power n. One more time. 1 plus x power n. What is this? nc0 with a 1, right? Followed by nc1x, nc2 x squared. Last one is ncn, x power n. If you let your x be 1, this is 1 plus 1, correct? Power n. This is nc0, this is nc1, this is nc2. Your x is just 1, right? All the way until ncn. What is this? This is 2 power n, right? So 2 power n is a summation of your nc0 until ncn. So why am I showing you this? Okay, then I'll wrap this up. Why am I showing you this? Because I don't want to use 1 by 1. I want at least 1. At least 1 is this. What I don't want is what? What I don't want is 6. Choose none. Okay, total is what? Total, if you add together, this is 61, 60, 60, 61, 62, and 60, 66, right? So it's 2 power 6 minus 6C0. Yeah, 2 power 6, guys. 2 times 2 times 2, you know, 2 power 5 is 32, 2 power 6 is 64, minus 1, answer is 63. But if you say, Terry, I really cannot do this. I really don't remember. What options do I have? Okay, you can do 1 by 1. So this is how it works, okay? Just that you need to know your NCR. Your number of ways will be 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. Okay, remember the symmetrical property of Pascal triangle I showed you. Just symmetrical one. 6C1 is 6. It is going to be the same as 6C5. You know, okay. NC, let me write here. Your NCR is the same as NCN minus R. 6C1 is the same as 66. 65, sorry. 62, how to calculate 62? Manually, without calculator. 6 factorial, 6 minus 2 factorial, 2 factorial. 6C3 will be the same. 6 factorial, 6 minus 3 factorial, followed by 3 factorial. Okay, 64, okay, I just show you the working. So 66 minus 4 factorial, 4 factorial. 65 is going to be the same as 6. 66 is 1. So actually this answer and this answer are the same one, right? 62 is the same as 64. So now this is actually 6. This is 4 factorial. Okay, guys, you minus, you're left with that. Okay, I do very slowly. 4 factorial, 2 factorial. This is 3 factorial, 3 factorial. This is 2 factorial, 4 factorial. See, these two are the same. 6 and 1, right? I do very slowly. Okay, how do you calculate this? 6, remember, 6 factorial divided 4 factorial is 6 times 5 times 4 factorial over 4 factorial, which you can cancel. Very slowly. I just write. Can I write 6 times 5? Is it okay to write 6 times 5? Or you want me to write the whole thing? 6 times 5, over 2 factorial. This one is 6 times 5 times 4. The cancel with 3 factorial. 6 factorial divided 3 factorial is 6 times 5 times 4 times 3 factorial over 3 factorial. You cancel it. So another 3 factorial. 3 factorial is 6. This one is going to be the same. So 6 times 5, 2 factorial. This one is 6 plus 1. So you should get 6 plus 15. This one can cancel. Cancel 20, right? This one is another 15, right? Another 6 and 1, right? So guys, what is this? This is 30, 21, 30, 41, 56, 61, 60, 62 plus 1, 63, right? Count without calculator. 63. But would you do this or would you use the total minus? Total minus is a lot easier. Yeah? So let's begin with this. 2 times n plus 1 p5 is n plus 6 n times n p4. So find the n. So the first thing is the formula for npr, as we know. npr is n factorial divided by n minus r factorial. So in this case, we get 2 times n plus 1 factorial divided by n plus 1 minus your r is 5 factorial. And that is equal to n plus 6 followed by n factorial divided by n minus 4 factorial. So the good news is you can cancel the n plus 1 minus 4, because your n plus 1 minus 4 is basically n plus 1 minus 5 is basically n minus 4. I do a bit slower here. This is n plus 6 followed by n factorial, right? Then you divide by n minus 4 factorial. So I just do a little bit slower here. Let's cancel out this 2. And what can I do with n plus 1? Now remember, like 5 factorial is basically 5 times 4 factorial. So I would change my n plus 1 factorial to n plus 1 followed by a single n factorial. Yeah, this is n factorial. Okay, wait, let me fix this. So why do we do that? Okay, so they're over to the right anymore. Why do I do that? Because we want to cancel with this n factorial on the right hand side. So you can cancel this, right? A light cut so you can see. So you are left with 2n plus 2 followed by n plus 6. As I bring over, what's your n? Your n is just 4. Okay, let's look at part B. This one involving combination. So a group of 7 students consists of 4 boys and 3 girls. 3 students are to be chosen to participate in the quiz. How many ways can they be chosen if exactly 1 boy is chosen? Okay, so here, remember, you have 4 boys, right? So maybe I write here 4 boys and 3 girls. You want exactly 1 boy. If I choose 1 boy, I must choose how many people? I must choose how many girls? You want to choose 3, right? Total, 2 girls. Yeah, quite simple, right? So this is 4 boys, I choose 1. 3 girls, I choose 2. All this should be done without calculator. But I hope you know 4C1 is just 4, right? So everyone, basic thing, NC1 is the same as NCN minus 1. This is something you should know. And this is equal to n. So for example, 4C1 is just 4. 3C2 is just 3. No calculation is required because, well, why 3C2 is 3? 3C2 is 3C1. It's the same as 3C1 because 2 is the same as 3 minus 1. 3C2 is the same as 3C, should I say 3C1 is the same as 3C3 minus 1, which is 3C2. Okay, equals to 3C2. So we know they are both the same, they are all 3. So answer is just 12, right? Okay, so like I say, all this should be done without using a calculator. Now, next, all girls are either chosen, are all chosen, or all not chosen. So 4 boys, 3 girls. All girls are chosen or not chosen. If I choose all the girls, I cannot choose all the boys. If I choose if I don't choose any girls, I have to choose 3 boys. Not all the boys are 3 boys. So there are 2 cases to consider. 4 boys, I choose none. 3 girls, I choose 3. 4 girls, I choose 3. 4 boys, I choose 3. 3 girls, I choose none. So what do you get here? Now, remember another thing, for NC0 is what? NC0 is the same as NCN, which is 1, right? So 4C0 is just 4. 4C0 is just 1, 1. There's only one way to choose none of them. There's only one way to choose all 3 girls. And 4C3 is just 4. 3C0 is another 1, so it's 1 plus 4. Answer is 5. Yeah. So like I said, all these questions I made it such a way that you don't need a calculator. You can count straight away mentally. Yeah, first part is permutation. They say that a cafe here, cafeteria, sells drinks in cups, either hot or cold. So each cup has 3 different sizes, small, medium, large. These 6 different cups okay, are arranged in a row for display, okay? So now find the number of ways the cup can be displayed if the cups for hot drinks and cold drinks are placed alternately. Okay, so hot and cold alternately. So you have 6 different sizes. We don't care whether the size is big or small, but they are different. So when you say alternately, we can have hot, cold, hot, cold, hot, cold. Or the other way around. We do cold, hot, cold, hot, cold, hot. The other way around, right? Now, the thing is, if I start with hot, it's 3, 2, 1, right? Isn't it? 6 factorial, 3 factorial, 6. Coal is 3, 2, 1 as well. So you can say number of ways is 3 times 2 times 1 or 3 factorial times another 3 times 2 times 1 times 5. You can write 3 factorial and then you times 2. Why do I times 2? So the first case I start with hot followed by cold. Second case I start with cold followed by hot. This is 3 factorial. You can write 3 factorial, but we still have to split because we remember you cannot use calculator. 3 factorial you can't do calculator unless you have to memorize it. It's 6, right? So this is 6. There is another 6 and another 2. Answer is 72. Now next, the cup of the same size are placed next to each other. So in the second case, the same size means we are talking about small, medium, large. So for example, the small one we put next to each other, the medium one we put next to each other, the large one we put next to each other. So within each one, right, it can be hot or cold. You know, the cup sizes for hot and cold is different, right? Like usually cold they use plastic, hot they use paper. You know that, right? Yeah. So let's say you need to do cold and hot first. So it's 2 factorial or 2 times 1 for small, 2 times 1 for medium, 2 times 1 for large. Now within this, there are 3 boxes. How many ways to arrange 3 boxes in a row? There's another 3 factorial, which is 3 times 2 times 1. So what you can do is you can say this is 2 times 1 power 3. Why power 3? Because 2 times 1 times 2 times 1 times 2 times 1. You can write 2 times 1 3 times, then followed by another 3 times 2 times 1. Yeah, again, you can also write 2 factorial power 3 times 3 factorial. So 2 factorial is 2, 2 power 3 is 8, 3 factorial or 3 times 2 times 1 is 6. Your answer is 48. So how do you show that NCR equals NCN minus R? So let's begin with the first formula. NCR is N factorial divided by N minus R factorial, isn't it? So this type of question, you have to perhaps look at the right hand side first. Remember the formula NCR is this, but then the second part is NCN minus R. So you're going to do N factorial, N minus R. I should start with N minus N minus R, N minus N minus R factorial, and followed by N minus R factorial. So how do you go from here to here? So actually it's easier to start from the right, going towards the left. But if you're starting from the left, to move to the right, you need to create this out of thin air. So what I do is, I first switch the position, R factorial, N minus R factorial. You understand this? Then you realize that this N minus N, this is N minus N plus R, which gives us R factorial. Isn't this the same as this R factorial over here? So what we want to do is we're going to go back towards that. So we keep writing the N factorial on top. This one we write a N minus bracket N minus R, whole bracket factorial, N minus R factorial. Now, which is basically the same as this formula here, NCN minus R. Yeah, that's how you show it. Now, you can also start from the right, move towards the left, because I think right towards the left is easier to understand, as in, okay, let's say if you start from the right hand side, you can use this RHS, right hand side, NCR. This is N factorial, N minus, this is N minus N minus R, N minus R factorial, N minus R factorial. So that is N factorial. This N minus N plus R is just R factorial, followed by N minus R factorial. We just switch the position, and that is your NCR, which is my left hand side. So instead of starting from the left, we can start from the right, yeah, and get our answer towards the left. Yeah, it's only 2 marks. So how many numbers between 400,000 and 600,000 can be formed from this digit? Okay, there are 6-digit number here. So we draw 6 boxes. 6 boxes. Now, when they say between 400,000 and 600,000, means you have to begin with 4 or 5. You cannot begin with 6. The moment you begin with 6 is more than 600,000, right? So how many ways can I begin? 2. And when we got 6 digit, you've taken 2 digit out. You're left with how many? Sorry, you're taking one digit out. You take either 4 or 5, one digit out. You take 5, right? This is what? 4, 3, 2, 1. So for non-calculator paper, this comes in handy. We don't write 5 factorial, we just multiply like this, right? And it's not difficult to do. You know why not? This 2 times 5 is what? 10. 10 times 12, 120. 120 times 2, 240. You can use brain to count. It's even easier than primary school maths with a lot of numbers that you have to multiply. The multiplication part is not difficult. It's quite simple. Okay, you can write other ways. Like some people write 2p1. Can, but 2p1 is just 2, right? So waste time, right? So I just write 2 straight away. Okay. Now, second part, Roman 2. How many of this number ends with a multiple of 3? So I draw 6 boxes again. A multiple of 3 means it ends with 3, 6, 9. So this is 4 and 5. Again, 2 ways, 3 ways. They are not related. You see, the numbers that we have that we begin with and number we end with, they are different set of number. So it's not going to affect anything else, right? But since you have 6, you've taken 2 numbers out, you're left with 4, 3, 2, 1, right? Isn't it? So the number of ways will be 2 times 4 by 3 by 2 by 1 by 3. Okay, again, all this can be done using mental arithmetic. 2 times 4 is what? 8. 8 times 6. 8 times 6, 48. 48 times 3, 144. Cannot. You can use any other combination. You can count like 1 by 1 manually, also can. Up to you. Now, moving on to part B, Aiden wants to choose 2 out of n textbook to bring to school on a particular school day. Given the number of ways he can choose this book, is 45. Find the value of n. Okay, so what do you do first? We write NC2 is 45. Our goal is to find n. So you can use back the formula. Now, I'll show you the slow way. The slow way is what? N factorial, n minus 2 factorial, 2 factorial. Now, from here, what do I do? What can I do with this n factorial? N factorial is as n times 1, n times 2 factorial, divide by n minus 2 factorial here, and 2 factorial. Actually, guys, you can actually cancel this and you can cut short. I think I told you guys before, right? NC0 is just 1. NC1 is just n. NC2, right? It looks like this, n minus 1, 2 factorial. If I ask you NC3, you got n minus 1, n minus 2, 3 factorial. It just goes in descending order. Then divide by the number of times appear, the R here, factorial. Okay? Now, next, we will simplify this further to n squared minus n. 2 factorial is 2. 2 times 45 is 90. So normally we can rearrange and factorize. Okay? Double bracket. What's the factor of 90? 90 to get 1. 9 and 10, right? Yeah? Again, you should be able to factorize without using calculator. Right? 9 and 10. This is minus. This is plus. N is positive. N cannot be negative. Your number of books is always positive. N is just 10. Given that the number of ways to arrange at most 2 items out of n item is 65. Okay, now the word is arrange. Arrange, you use permutation, not combination. Now, when we say at most 2 items means what? Ready? I can arrange 0. I can arrange 1. I can arrange 2, maximum 2. So you start with NP0, NP1, NP2 equals 65. Okay, remember the formula for NPR. NPR is given as what? N factorial divided by n minus r factorial. So what is NP0? It's 1, right? Isn't it 1? I got n item, I don't arrange anything. Not arranging anything is 1 way, right? NP1 is, guys, NP1 is just n, right? NP2 we n factorial, n minus 2 factorial, 65. So you can actually simplify this. This will give us n minus 1, n minus 2 with the factorial, n minus 2 factorial. Can we cancel them? So the more cancel here, what we have is a quadratic equation. It's actually a quadratic, but the n square is there, but n cancel already, so it's quite easy. You're left with 1 plus n squared equals to 5. Yeah, very easy. N squared is 4. I made a mistake here, sorry. N squared minus n 65 here. Oh man, I made a mistake here. 65. So this is 65. This is 65. This is 65. This is 64. Square root of 65 is what? 8. Again, do you need to put plus minus? No. N is number of item. The number of item cannot be negative. Yeah, so we just take the positive value. N is 8. A jar contains 4 different types of sweet. There are at least 3 sweets of each type. Raj selects 3 sweets from the container. Calculate the number of different sweets, that he can select. So this one is quite challenging, I would say. Why? So because you have 4 types of sweet, each one has at least 3, so you can choose, and he wants to choose 3 sweets, right? So there are 3 cases to consider. So first of all, can he choose 3 different sweets? Case number 2, can he choose 2 different sweets? Case number 3, can he choose, you cannot say 1 different sweet, right? So you say all same sweet. So now, how do you choose 3 different sweets? This is choosing. You got 4 different sweets, right? I choose any 3. For example, your sweet can be orange, strawberry, apple, and what? Mint or some. So you can choose any 3. So I can choose orange apple, orange strawberry apple, or I can choose strawberry apple, maybe mango, orange, orange strawberry mango, or last one I can choose orange apple mango. So there are actually 4 ways. You can work it out. 4C3 is actually 4. Now 2 different sweets, however, it's a bit unique. Why I say it's unique? Because first you choose two candy. Let's say, for example, I choose orange and strawberry. Now the problem is one of them has to be repeated. I can have 2 oranges and 1 strawberry, or 1 orange and two strawberry. So first we decide which 2 candy I have to choose, which 2 sweets I have to choose. Then I need to choose which one. I need to decide which one to be repeated. Like orange strawberry, there are 2 more combinations. Maybe orange apple, I can also do orange apple, orange apple, isn't it? So you have to times 2. You can either times 2 C1 or times 2. What does this 2 C1 represent? Choose 2. Okay. Choose 1 to be repeated. Should I write this here? One of them has to be repeated. 2 out of 4. Remember, you have, let's say, example, orange, apple, strawberry, mango. I got 4 different candies. I can choose orange apple, orange strawberry, orange mango. Some more? Apple, strawberry, apple, mango, strawberry, mango. So they are how many ways? 6, right? 4C2 is 6. But each one, right, you need to decide which one to repeat. Like, for example, strawberry, mango, I can have strawberry, mango, or strawberry, mango. One of them to repeat, right? So that's why the times 2. If you don't have times 2, you can write times 2C1. Yeah, 2C1 times 2 is the same now, right? So I just put a note here. 2C1 simply means choose 1 to be repeated. You choose 1 candy flavor to be repeated. Okay, case number 3 is very simple. Choose all the same candy. I got 4 candy, right? I choose only 1 flavor. Like, for example, all 3 orange, all 3 apple, all 3 strawberry, all 3 mango. Yeah? So that is only 4 ways, right? 4C1 is 4, right? Okay? So this question came out past before. You see my example also, I don't know whether you remember, but my example was not sweet, that's something else, right? So what is 4C3? 4C3 is 4. Remember, NCN minus 1 is the same as NC1, which is N. So 4C3 is 4. It's the same as 4C1, which is 4. 4C2, if you cannot do mentally, right, 4C2 is actually 4 factorial, 4 minus 2 factorial, 2 factorial, 2C1 is 2. 4C1 is 4. Yeah, if you can do mentally, just do like this. Okay, what is 4 factorial? 4 factorial is 4, 3, 2, 1. This is 2 factorial, which is 2 times another 2, you times another 2. Another 2 here. So what is this actually? Cancel them. Cancel this and this. Cancel this and that. That's 12, right? So it's 4 plus 12 plus 4. Answer 20 ways. So a number is formed using 7 digits. 0, 1, 2, 3, 4, 5, 6. How many different 3-digit number can be formed if the digit can be used more than once and it cannot begin with 0? Okay, so here's the thing. Can be used more than once means with repetition. It's just that it cannot start with 0, right? You got 7. Okay, if you cannot start with 0, this is your first digit. You cannot start with 0. What can we start with? You can start with what? Come on. You can start with 1, 2, 6. How many options do you have? 6. Huh? Okay. Okay, sorry. They say 3-digit number, not 6-digit number, not 7-digit number. So 3-digit number means the first one is 6. Yeah. One more. Okay, 6. Next one is 7. Why 7? I can also start with 7, right? 7, right? So number of ways is 6 by 7 by 7. Can you use brain to count? 49 times 7. 49 times 6. If you cannot use, the normal way, just count like this. Actually, I can think 50. Just think 50 times 6, 300. Then you minus 6, 294. If not, you count mentally 54, 294. Okay? Given that no digit can be used more than once, find how many 4-digit number more than 4,000 can be formed. So we draw 1, 2, 3, 4. Now, remember, you're using back the same number, 0 to 6. Okay, maybe I just leave it at first. You want it to be more than 4,000. More than 4,000 means you have to begin with 4, right? 5 or 6. Okay? Now we cannot repeat. We cannot use back the same number, so we got to reduce by 1. So the first case, anyone? 3 ways, right? Next one. Remember, you have 7 digits. Right? Let me just show back here. 7. I've taken 1 out. Left with what? 6. Take out one more. 5. Take out one more. 4. So this is 3 times 6 times 5 times 4, right? Okay, can you use brain out? 3 times 6, 18. 18 times 20. This is 20, right? 360, isn't it? Okay, next. How many of these 4 digits from Roman 1 are divisible by 5? Okay, remember, because it is, when you say divisible by 5, you should end with 0 or 5. Now, then you have 4, 5, 6 here. So this is a case where when you choose 5, it does affect the selection. If you choose 4 or 6, it doesn't affect the selection for the last digit. So you have to split to 2 cases. Case number 1, we begin with 4 or 6. Case number 2, we begin with 5. So we draw 1, 2, 3, 4, 4 or 6. 1, 2, 3, 4. You begin with 5. So this is 0 and 5. This is also 0 and 5. Now take note. When you begin with 4 or 6, right? There are 2 ways. You should end with 2 ways as well, 0 and 5. And I have 7 digits to begin with. 7 digits, right? I've taken 2 out. Left with what? 5 and 4. So the first case, you have 2 times 5 times 4 times 2. This is 10, right? 10 times 8, 80. The second case, this is 1, this is 2, and 5 and 4. Same like just now. So 1 times 5 times 4 times 2. Yes?
1.
Okay, sorry. This one have to reduce by 1. Sorry, this is 1. Because you cannot begin with, you can't end with 5 anymore. So this is 1. So that's 20. So total, how many cases? How many ways? My total will be 80 plus 20. Answer 100. So that NC3 minus NC1 equals to this. So let's begin with the left-hand side. Okay. NC3. What is NC3? NC3 is n factorial n minus 3 factorial 3 factorial. NC1 is n factorial, n minus 1 factorial, 1 factorial. Actually, can I just write n? Yeah, NC1 is just n, right? You don't need to show again, right? Now, let's simplify this. This is n minus 1, n minus 2. Yeah, remember I already explained to you earlier, we can actually cut short. I don't have to write this line, actually. You can just cancel it. But anyway, let me write like this for you. Can we cancel it? This will give us, or maybe I expand later. I expand first. N squared minus 3n. This is 3n, huh? 3n plus 2. 3 factorial is 6, right? This one is n. Now, the problem with this n is that they don't have the same denominator. This n means n over 1, right? So what should I do? I should multiply top and bottom by 6. Okay, so as I multiply top and bottom by 6, I don't want to expand this first, guys. I don't want to expand this first because I think it's just easier to factorize it later on, right? Now, we can take out n from here. As in, we take out this n, left with n squared minus 3n plus 2 minus 6 over 6. You know what happened here now? I took out my common factor. My common factor is n and n. I took it outside. So that's why you're left with minus 6. So we can simplify further. Minus 3n minus 4 over 6. And we can factorize this now. N minus 4 and n plus 1. Okay, in fact, I don't need to make our life difficult. Please have a look at the answer above. Isn't it n plus 1, n minus 4 over 6? And that is equals to your right-hand side. Now, with that, we can use this result to solve part B. Now, question say, this whole thing is now equals to n. So we can just copy n plus 1, n minus 4 over 6 factorial. Over 6, not 6 factorial. It is now equals to n. Now, the thing is, if you multiply over, what do you get? This is a bit long. Okay, I have to expand this again. Again, n squared minus 3n minus 4. This is 6n. Right? Guys, I move this out a bit. No space. This will be what? I bring the 6 over. Now, without expanding the bracket, because I don't want to convert this into a cubic, I just bring the 6n over. Now, I know some of you may say, can I actually cancel that? Actually, you can, because n is a non-zero value. But let me just put it together. This is n squared minus 3n minus 4 minus 6, just like just now, right? I factorized my n. Look, I'm factorizing my n here, I took it out. I'm left with this and a 6. I just put them together. Now, with that, this is n squared minus 3n minus 10. What's the factor of 10? Factor of 10 should be 2, and to get 3, I must use 2 and 5. Plus 2 minus 5 equals 0. Now, your n cannot be 0 because your n is greater equals 4. So there's only one answer. N is 5. N cannot be -2, n cannot be 0, n can only be 5. The given table shows the number of coins in a coin box. The coins of the same value are different, right? So like, for example, your 10-cent coin, the year is different, 2017, and then another 20-cent coin, 20 pence coin is another, even the same value, they can have different year, right? Different year it was minted. So all coins are arranged in a row. How many different possible arrangements if all 3 10-pence coins are next to each other in between 2 50-pence coins? So we have to draw, these are the 50, 3 10 together, and another 50, right? Now you see I have 20. 20 you got how many? 4. 4 20 here. So these are 20. So how many ways to put the 15? 2 and 1, right? How many ways to put the 10? 3 2 1. Okay, always remember, this one is actually tied together as a block. It's a one block here. So you have a block of 10 and 50 pence coin together with another 4 20-pence coin. So how many ways we can arrange them? So you're going to think of this as like one block, 5, 4, 3 2 1, or 5 factorial. So the number of ways will be, so let's handle the 50 pence first, 2 times 1 or 2 factorial. 10 pence is 3 factorial, or we say 3 to 1. Then a block of the 10 and 20 and 50 together is 5 by 4 by 3 by 2 by 1. You can write 5 factorial, but remember 5 factorial, you may work out separately is 120. Like some of you have done this so many times, right? What is 1 factorial? 1. What is 2 factorial? 2. What is 3 factorial? 6. What is 4 factorial? 24, right? What is 5 factorial? 120. What is 6 factorial? 720. Basically, just multiply. Like 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. 24 times 5, 120. 120 times 6, 720. Just keep multiplying with the next number, right? So you can write this one first. This is 2. This is 6. This is 120, right? Okay. So 2 times 6 is 12. 12 times 12, 144, right? But there's another 0 at the back. So do you really need to use calculator? Do you need to use the long way? No. Yeah? Just multiply directly. Okay, use ring. All right. Now let's look at part B. Part A is about permutation. Part B is about combination. The keyword is chosen. For part A, the keyword is arrange. For part B, the keyword is chosen. When you choose, you don't arrange them, is combination. Now, 3 coins are chosen at random. Okay, the word chosen appeared first here, right? So find a different number of ways the coin can be chosen if all 3 coins are of the same value. Okay, so remember, maybe I list out here. Okay, let's talk about 10 pence. You have 10 pence, 10p, I put 3, 20p, I have 4, 50p, I have 2. So when I say all 3 coins are of the same value, means what? Guys, what does that mean? I can choose all 3 from 10 cents, 10 pence, all 3 from 20 pence. Is it so? Right? So that means can you choose 3 from 50 pence? No, not enough. Not enough, I only have 2. Right? So the thing is, 10 pence I can choose. Sorry, you cannot write 10. How many do I have? I got 3. I take all 3. Right? I take all 3 from here. 20 pence. Okay, should I write this for you? Okay, let me do like this. Case number 1. All 3 are 10 pence. Case number 2. All 3 are 20 pence. So all 3 10 pence means 3, I choose all 3. All 3 20 pence is 4 of them. Since I got 4 of them, I choose any 3. What is 3C3? 1. What is 4C3? 4. Answer is 5. Okay, second one, the total value of the coin is more than $1. Total value of the coin is more than $1. Okay, so in what situation you get more than $1? Now, the first thing I want you to think, even if I take 320, can I get $1? Cannot. In order to get more than $1, you need how many 50? 250. You definitely need 250. 250 plus 110, you got $1.10. 250 plus 120, you got 120. Any other combination? Try all. It's not a triangle. It's a word. Sorry for the ugliness. All. Okay. So you gotta think this way. In order for you to get, maybe I write here 10 pence, I got 3. 20 pence, I got 4. 50 pence, I got 2. In order to get more than $1, I must choose 2 from here, 1 from here, 0 from here. Or I can choose 2 from here, 1 from here, 0 from here. Is there any other combination? Can I take 3 from here? 3 times 20 is 60 only, not enough, right? So there are only 2 cases to consider. So you can write 3 10 pence, I choose 1. The 4 20 pence, I choose none. Don't want to write this also can, because 4C0 is 1. Then 2C2, followed by 3, I choose none. 4, I choose 1. 2, I choose 2. So this is 3 times 1 times 1. 2C2 is 1. 4C0 is 1 as well. 3C0 is 1, 4C1 is 4, this is 1, so it's actually 3 plus 4, answer 7. I'll purposely use smaller number that you don't need to use a calculator. Question number 9. A 3-digit number is to be formed using 3 different numbers selected from 1 to 8. 1, 2, 3, 4. No 4. No 4 to 8. There's 7 digits here. Yeah, 7 digits. Okay, how many codes can be formed? Or how many number can be formed? 1 is not prime number. So if there's no restriction, okay? When there's no restriction, right? You can choose any lah. So since I got 7 digit, I only arrange 3, so it's 7, 6, 5. So all these you can use mental arithmetic, right? 6, I'll times with 5, so 6 times 5 is 30. 7 times 30, 210. Hey, no calculator, please. You will suffer in exam. Only prime numbers are used. Okay, if I say only prime numbers are used, your prime number will be what? The prime numbers are 2, 3, 5, 7. Okay, so we need to draw 3 boxes. Now this is easier because you have 4 ways here, 3 ways here, 2 ways here. Isn't it? Because you have 7 digits only, there's no 4. Notice? There's no 4. Yeah, only 7 digits. So with that, your number of ways will be 4 by 3 by 2, 12 times 2, 24. Now, Roman 3, the number is an odd number. Now, what determines whether it's odd or even? Is the last digit. In order for it to be odd number, it must end with 1, 3, 5, 7. So this one you have 4 ways. The rest, remember you got 7 to begin with, you've taken 1 out, left with 6, taken 1 out, left with 5. So the number of ways is 6 by 5 by 4, 30 times 4, 120. So Evan wants to buy 4 revision books from shop. He can choose 4 mathematics books, 3 science books, 2 history books. Find number ways he can do so if he didn't buy any mathematics book. Okay, so let's begin. Choose. Keyword is choose, not arrange. So he didn't buy any mathematics book. So maths book you throw away. So you buy from science and history. So what you can do is this: 4 mathematics books, science and history put together, there are 5 others. So he wants to buy 4. So if you don't buy any maths book, you have to buy all 4 from others. Others means 3 sciences and 2 history. So answer, you can write 4C0, 5C4. Now the 4C0 actually you don't write because 4C0 is 1. 5C4 is 5. Answer is 5. Okay, Roman 2. He bought at least 1 book from each subject. So remember, you got 4 mathematics, 3 science, 2 history. When we say at least 1, right, means I can buy. Now remember, I have 4 books, right? If you buy 1 each, right, you got 1 spare. The spare can go to the maths book. The spare can go to the what is this? Science. My science looks ugly. This is S for science. The spare can go to your history book. So you can do it this way, right? Remember, you put assign 1 for everybody, but there's 1 extra. So where the extra goes to, the first one goes to maths, second one goes to science, third one goes to history. So this is 4C2 times 3C1 times 2C1, followed by 4C1 times 3C2 times 2C1, followed by 4C1 times 3C1 times 2C2. Okay, so guys, what is this? 4C2? 6, right? Okay, can I work it out separately? Because we've done this a few times, guys. 4C2 is 4 factorial, divide 2 factorial. So I just do 4 times 3, 2 factorial. Isn't it 6? Can I do this shortcut? Remember, I say this for NC2 is n minus 1, 2 factorial. So I'm just going to write this as 6 times 3 times 2, and 4 times 3 times 2, and 4 times 3 times 1. Okay, so the first one is 36. Second one, 12 times 2, 24. Hey, no calculator. And this one is 12. Answer is what? 72. A code is formed using all the letters in the word chaos. Find number of different codes can be formed if it begins with a consonant. It begins with a consonant. How does it begin with a consonant? 1, 2, 3, 4, 5. Your consonant is C, H. S. Sounds like a school, Catholic high school, right? So how many ways? 3. You got 5. Taken 1 out, left with 4, 3, 2, 1. So your number of ways is 3 times 4 factorial. Guys, 4 factorial is, what is 4 factorial? Should I write one by one? I don't write 4 factorial, cannot do mentally. 4 times 3 times 2 times 1. But you can actually work out it's 24. It's 3 times 24. Answer 72. Okay, next. The vowels are next to each other. Okay, the vowels are next to each other. So we draw, vowels will be A and O. Tie them next to each other. So we draw 2 more boxes, 3 more boxes. How many ways the vowels next to each other? Answer 2 times 1, 2 factorial, right? Okay, how about the rest? You can remember treat this like a block. This is a block. How many ways to arrange this? This is 4, 3, 2, 1. I guess this is quite easy compared to just now, right? 2 times 4, 3, 2, 1 is 2 times 24. Guys, what is 2 times 24? 48. Yeah, 48, 72 and 48. Let's move on to part B. A company has 3 staff from administration department, 5 from sales, and 4 from technical department. Committee of 7 to be formed from the staff of the company. How many ways it can be formed if all the sales staff, all the staff from the sales department are in the committee? Okay, sales, how many do you have? You have 5, right? 5 sales. I will take admin and technical combined together 7 others. It's easier to do this way. Because if you want to choose 7, complete set of 7, and you've taken 3 sales staff, the rest should be 4. Yeah. So sales 5, I choose 3. 7 others, I choose 4. Sorry. There are 5 sales staff. I choose all 5. Sorry. So this is 5. This is 2. 5C5, 7C2. Okay, 5C5 is 1. 7C2, right? Let's use the method. Remember I said NC2 is n minus 1, 2 factorial. So you take 7 times 6 over 2 factorial. 2 factorial is 2. So this is 1 times 21. Answer is still 21. There are 21 ways. Okay, second. The committee consists of staff from exactly 2 departments. Okay, so when I say exactly 2 departments, means you're going to throw 1 department away. For example, you take admin and sales, right? Next one, you take admin and technical, or sales and technical. So there are 3 cases to consider. Okay, so let's take admin and sales combined. How many people from admin? 3. Sales, you got 5 total, 8, right? Admin and technical, 3 plus 7, 3 plus 4, 7. Yes. Then sales and technical, sales got 5. Technical, you got 4. 5 plus 4, 9. And remember, you're choosing how many people? You're choosing 7. So basically, you say the first one, you have no technical. Second one, no sales. Third one, no admin. So 3 different cases to consider. The first one, 8, I choose 7, right? 8, I choose 7. Second one, 7, I choose 7. Third, 8, sorry, not 8, 9. 9, I choose 7. So 8 choose 7 is just 8, right? Remember, NC1 is N. 7 choose 7 is 1. Okay, this one, how to do it? 9C2, remember the same formula? 9 times 8, 2 factorial. This one is 8 plus 1, you can write 9. This is 72 divided by 2, 36. 8 plus 1 is 9, 9 plus 36, 45. Yeah? Find how many different 6-digit number can be formed using this if each digit may only be used once. Okay, so guys, how do you do this? 6 different digit. Each digit can only be used once. So for me, I draw 6 boxes. 1, 2, 3. Oh, okay, so the first one, no need draw boxes. Can I write 6 straight away? 6 factorial? Or 6 by 5 by 4 by 3 by 2 by 1. Yeah, you know it's 720, right? No need to use cannot use calculator. 6 factorial is 728. If not, you come number 1. 30 times 12 times 2. Okay. Now, how many of this number not divisible by 5? Now, not divisible by 5 means you cannot end with 5. Yeah. So let's draw 1, 2, 3, 4, 5, 6. Not divisible by 5 is 1, 2, 6, 8, 9. Right? Okay. So how many ways here? There are 5 ways. The rest, any number, right? You got 6 digits. So reduce by 1, left with 5, 4, 3, 2, 1. So number of ways you can write 5 factorial of 5, 4, 3, 2, 1. We know 5 factorial is 120. 120 times 5, 600. You can work it out separately. Yeah, you can work it out separately. I think this is quite easy. Right? Yeah, not divisible by quite easy. Just cannot end with 5. Okay, now next, Roman 3. How many of this even and more than 600,000? So I draw 1, 2, 3, 4, 5, 6. If it's even, right, it must be 2, 6, 8. More than 600,000 means you can start with 6, 8, or 9. Now notice that if you begin with 6 and 8, it does affect the selection of the last digit. If you begin with 9, it doesn't affect. So in this case, in this situation, you got to divide to 2 cases. Case number 1, we begin with 6 or 8. Case number 2, we begin with 9. So I draw 1, 2, 3, 4, 5, 6. If you begin with 6 and 8, you should end with 2, 6, 8. So there are 2 ways here. This one you can reduce by 1. So for example, if I choose 6, I cannot choose 6 anymore. I can choose 2 or 8. So this is not 3, this is 2. And you got 6. I've taken 2 out. Left with 4, 3, 2, 1. So your number of ways is 2 times 4, 3, 2, 1 or 4 factorial. 4 factorial is 24. 24 times 2, 48. 48 times 1 more 2, 96. Hope you can do that mentally. Case number 2. 1, 2, 3, 4, 5, 6. If you begin with 9, you can end with 2, 4, 2, 6, 8. Doesn't matter, right? 2, 6, 8. So how many ways can you begin with? 1, 3. This one will be what? 4, 3, 2, 1. So the number of ways is 1 by 4, 3, 2, 1, which is 24. 24 times 3, 72. You see, you must end with 6 or 8, right? If I start with 6 or 8, if you reduce the option, for example, if I start with 6, I cannot take 6. My number option reduced by 1. But you still have to list the 6 and 8, because we don't know whether to pick 6 or 8. Okay, what is your total, everybody? Your total will be 96 plus 72, 168. Yeah? Guys, the next one I got inspiration from Subway. You know Subway? You have to choose the bread, you have to choose the meat, you have to choose the veggie and sauce, right? So here, to order a sandwich from a shop, a customer must choose a type of bread, a type of meat, and 4 different types, from 4 different types of bread and 6 different types of meat. And then customer must choose none to all types of vegetables, and sauces to be included in the sandwich. There are 5 types of vegetable, 3 types of sauces, 5 number of different ways a customer can choose a sandwich if the customer chooses all vegetable and exactly 2 types of sauces. Okay, let's do the bread first. 4 bread, 6 meat, 6 meat. Okay, how many veggie? 5. And 3 sauces. Okay, so the first case, they say the customer chooses how many? You need to choose 1 bread. I cannot have 2 bread. How many meat? Also 1. But he chooses all 5 veggie. A very healthy person. And exactly 2 types of sauces. So in this case is 4C1, 6C1, 5C5, 3C2. Understand? 4 types of bread. Parmesan, oregano. What else? Wheat. What else? Italian. Last one? Honey oat. Something like that, right? Is it? Got honey oat. This one is 6. 5C1 is 1. 3C2 is 3. 24 times 3, 72 again. Alright. Okay, next. They say the customer chooses a particular type of bread and meat. So that means when you choose a particular type of bread and meat, right, you cannot list the choices anymore. You already chosen, it's only one way, right? You already chosen the bread and meat. So what our concern is now the veggie and sauces. Now they say at most one vegetable and at most one type of sauce. How do you do at most one vegetable? You're gonna do 0 and 1, right? Like for example, I don't choose any veggie, or I choose one veggie. Correct? Okay, maybe I list out first. Sorry, I choose one. They say at most one veggie, at most one sauce. So this one, they just eat meat one. Hey, everyone, is there anyone that you've seen buying Subway, take the meat, take the bread, no veggie, no sauce? All right, but this case can happen. 0 and 1, some more. At most one sauce, right? Sauce is S. Sorry, I shouldn't put C. Sauce is S. Okay, so this one is one veggie, no sauce, one veggie and one sauce. So there are 4 cases to consider. So the first one is very weird. It's 5C0, 3C0. You don't choose any veggie, you don't choose any sauce. Or 5C0, 3C1. Next, 5C1, 3C0. Lastly, 5C1, 3C1. So this is 1 by 1. Just anything C0 is 1. This is 1 by 3, 5 by 1, 5 by 3. So let's work out 1 plus 3 plus 5 plus 15. Answer 24. If you find this helpful, do give this video a like. You can also share in the comment which topic you'd like me to cover next. If you need more practice, my MS books are available on Shopee and Lazada. Just search Teliti. And if you're looking for more structured learning, you can explore my e-course or join my classes. Remember to subscribe. I'll see you in the next lesson.